എന്റെ തൃക്കാവിലമ്മേ, മഴക്കാരല്ലേ വരുന്നത്, എന്റെ കച്ചവടം ഇന്ന് വെള്ളത്തിലാവുമല്ലോ. എന്തൊരു പ്രശ്നം മക്കളെ, ഈ നശിച്ച മഴ കാരണം എന്റെ പാല് മൊത്തം വെള്ളത്തിലായി. ഇനി കച്ചവടം നടക്കട്ടെ.
ചെറിയ പ്രശ്നത്തിന് മാമി പാലിട്ടാ പോലെ
ഒരു മിനിറ്റ്. ഇതെന്താ സംഭവം നിങ്ങൾക്ക് അറിയാമോ? ഇതിന്റെ ശാസ്ത്രം ഞാൻ പറഞ്ഞുതരാം.
ജലം പോലുള്ള ദ്രാവകങ്ങളുടെ പ്രത്യേകതയാണ് പ്രതലബലം അല്ലെങ്കിൽ സർഫസ് ടെൻഷൻ. ഇവിടെ പാൽക്കാരൻ ചേട്ടന്റെ പാൽപാത്രം തോർത്തുകൊണ്ടാണ് മൂടിയത്. അതിനുശേഷം പാത്രം താഴത്തേക്ക് കമത്തുമ്പോൾ വെള്ളം താഴോട്ട് പോകുന്നില്ല. ഇതിനു കാരണം പ്രതലബലം തന്നെയാണ്. ഇവിടെ ജലതന്മാത്രകൾ തുണിയിലെ ചെറുസുഷിരങ്ങളുമായി ആകർഷിക്കപ്പെടുന്നു. ഇവിടെ സുക്ഷേപ ബലം കാരണം അല്ലെങ്കിൽ അഡിസീവ് ഫോഴ്സ് കാരണം ജലതന്മാത്രകൾ തുണിയുമായി പറ്റിച്ചേർന്ന് ഒരു പാട പോലെ പ്രവർത്തിക്കുന്നു. അതുകൊണ്ട് പാലിന് പുറത്തേക്ക് വരാൻ സാധിക്കുന്നില്ല. പ്രതലബലം കാരണം പാൽക്കാരൻ ചേട്ടന്റെ കച്ചവടം പൊട്ടിയില്ല. എന്താല്ലേ?
Imagine a world without colors. Sounds dull, right? Let's explore how dyes spice things up. Dyes have been used around for thousands of years, dating back to ancient Egypt, where they used plants to create stunning hues. Fast forward to the 19th century, when a young chemist named William Perkin accidentally discovered first synthetic dye, Mauve. That mistake revolutionized the textile industry. So what makes dyes so magical? It's all about chemistry. Dyes are molecules that absorb certain wavelength of light and reflect others, creating the colors we see. There are natural dyes from plants and insects, synthetic ones made in lab. Each has its own unique properties and uses. From your clothes to the food you eat, dyes are everywhere. Next time you see a burst of colors, think of the rich history of science behind it.
Wonders in science. What if this coin could be heads and tails at the same time? In quantum physics, this is superposition. Particles exist in multiple states until you look. It's not magic, it's science. Observing it forces one outcome. Welcome to the quantum world. In simple terms, a quantum system, such as an electron or a proton, can exist in a combination of multiple states until it is measured. This is often illustrated by thought of experiments like Schrodinger's cat, where the cat is theoretically both alive and dead.
Wonders in science. Chameleons mostly live in the rainforest and deserts of Africa. The color of their skin helps them blend in with their habits. Chameleons that hang out in trees are usually green. Those that live in deserts are most often brown. Why they change color? Trail lizards change color primarily for camouflage, blending it with their surroundings to hide from predators or to ambush prey, and sometimes to regulate their body temperature by absorbing more or less sunlight depending on the color they display. The color change is achieved by manipulating pigment cells in their skin, allowing them to darken or lighten depending on the situation. Melanophores are the pigment cells that permit color change, and the concentration of pigment granules within these cells determine the type of color that is produced. In general, the animal appears lighter colored when the pigment is concentrated and dark when pigment is dispersed throughout the cell.
Did you know the shape of snowflakes? It's hexagonal, right? How, when water cooled, become hexagonal? In solid state, molecular motion is minimum and molecules become oriented so that the maximum number of hydrogen bonds is formed. Thus, it is ordered, strong, extended 3D open lattice structure. This ordered arrangement of atoms in ice account for the symmetry of ice crystals in snowflakes, intricate hexagonal shapes of snowflakes.
Triple point. At the triple point, water freezes, melts and boils at the same time. Every known element has its own unique triple point. So let's see how it goes. And thus is hydrochloric acid, when I add copper sulfate, turns green due to copper chloride complex formed. When I add some aluminum, hydrogen gas is formed, and if I ignite that, it looks blue due to copper ions in solution.
Have you ever wondered why meteors, also known as shooting stars, glow with different colors as they streak across the sky? When a meteor enters our atmosphere, it's traveling at incredible speeds, typically around 40 to 50 kilometers per second. As the meteor encounters air molecules, it begins to heat up and glow. The color we see depends on the temperature of heated air and meteor. As the meteor interacts with the atmosphere, the air molecules become ionized and excited. This means that the electrons in the air molecules move to higher energy levels. When these electrons return to their ground state, they release energy in the form of light, which we see as the meteor's color. The composition of the meteor itself can also influence its color. For example, iron-rich meteors tend to produce yellow colors. Stony meteors tend to produce blue colors. And cometary meteors can produce a range of colors, including green or purple, due to the presence of organic compounds.